So real quick, I know you asked about part B. I apparently don't care. I'm gonna talk about A real quick, then I'll come back to B. So if I gave you a problem, log base 3 of 15 minus log base 3 of 5, what would you do?
Divide.
Sure, so tell me exactly.
So 15 over 5, right?
So just this?
Log 3.
Good. Okay. Like it. Some people stop there.
Yeah.
That doesn't make any sense. You know what 15 divided by 5 is?
It's 3.
Okay. Some of you guys stopped here.
Yeah. Yeah, it's
That
supposed to
doesn't
be
make any sense.
one.
You know what log base 3 of 3 is?
It's 1.
Yes. Okay.
Yeah, that's right.
Okay. You guys all with me? So when I say simplify, I inherently mean all the way, right?
Yeah, okay.
So for the other problem for part B, everybody has something like, right? Is that the same thing you guys have? No, okay. So it's this. So what's the first step here? Good. Log base m of x plus 2 over x squared minus 2x plus 8. That's the first step, not the end, right? So I gave you half the points for the problem if you did that because you get the log property correct. But of course you do the exact same thing you would do here. You just you reduce it. Now be very careful. You can't forget what we know from before. You can't kill x's, you can't divide it, you can't do that shit. What do you have to do? How do I simplify this? You factor them out. Cool. How's it factor? Two and four? Cool.
Positive and 2.
Yes. The big one's negatives, and the middle's negatives, and the these cancel, correct? So what's wrong if I say this? This is incorrect. I am making a mistake right now. I have made a mistake. Why is that wrong?
Because you don't have a 1 over the top.
Where was the x minus 4? On the bottom. How the hell did it come up top? So this is the 1 over. So you guys went one further step, which is okay. It doesn't really get you anywhere that matters, but is that all right? So basically, that's exactly what you do with that problem. Okay. So don't forget, variables are just numbers. Whatever you would do with the numbers, you have to do the same thing with the variables. What would I do with these numbers? Hopefully you would make that 3, you would reduce it. So I'm going to do the same thing with the letters, because letters are numbers that I don't know yet, so they work the exact same way. I try to reduce it, yeah. Let me see, let me catch up here. Did you, oh, I'm showing corrections in.
Yeah, it goes, so this way, yeah, because this way is going down, and this way goes down. Okay. Which is 18. Yeah, okay, yeah.
Good. Yes. All right, let's see. Everybody got your quiz back? Okay. So put the distribution up on the board, so you can take a look at that if you want to. Quiz was a bit rough. I'm pretty sure everybody should be done with chapter 6 homework, so if that's not true, you need to be. And once you get a little bit of practice with these things, they shouldn't be overly evil.
Yeah.
Any other questions from homework stuff?
Wait a minute. What homework is that? 7-1?
Yeah, it
I
could
think I
be
did.
anything.
I think I did okay with that.
Okay. I could go to a different section.
7-2 is what
Okay.
I'm working on now. But you know, it's nothing that I shouldn't know. It's just stuff that I commit to memory. I like the cosecant and the secant and how they all relate. And
Okay, yeah, okay. So it's still relatively new to a lot of us, the whole idea of this trig stuff. So let's do this. If there's no specific questions, I want to kind of review where we got to and then kind of build on that.
we get to do corrections on quizzes.
Say what? Sorry? Say again?
We get to do corrections on quizzes.
Yep.
Should have been such an easy.
So of course you can correct everything in this class except final. Yeah, the appropriately named final. All right, so let's see. Where did we leave off? So yesterday we did some proofs of what the sine of 30 is and so forth, right? And you need to start memorizing these things. So I think I did show you the connection between the unit circle and triangles. Because if I'm at a certain angle, I've created a triangle, correct? And this makes almost too much sense. If I have one trig function that talks about how big y is, it's going to get bigger as my angle rotates here. The y piece keeps getting bigger. So that makes sense why sine starts off at 0, because on the x-axis there's no y. The minute I start to lift off of the x-axis, I start getting a y piece. So my sine gets bigger and bigger and bigger. You guys all with me? So far we've basically lived in the first quadrant. So we have to talk about all the other quadrants. Okay, let me stop for a minute. All right. So a couple things. If I say, what is the sine of 60 degrees? Does anyone have a way to remember that yet? You can just straight up memorize it. You can do what I suggested. You can find somebody else who has a different way to look at it.
Like a half or something.
What is sine like? X or y? What's sine like?
Y.
Sine like y.
Square
Is
root
60
3/2.
closer to the y-axis or the x-axis?
Closer to Y.
Closer to the y. So sine should be more out of its shell. It should be bigger, right? This shirt doesn't really help me do the turtle. This is the way that I think about this. So I'm a little biased. I think it's a good way, but you don't have to think of it this way. But that's why. If sine likes y and I'm close to the y-axis, sine should be the bigger option. Okay, so that means you have to know what the options are. It could be 1/2. It could be rad 2/2. It could be rad 3/2, right? For the three angles in the middle that we have to know. So the biggest option, rad 3/2. So I don't know if my language gets confusing sometimes. I say sine likes y just because it's a quick phrase to remember how to memorize when sine is what. And the reason I say sine likes y is because sine is defined to be the y side divided by the hypotenuse. So if the y side is getting bigger, the sine is getting bigger. So sine goes like y. Sine likes y. Yeah, okay. So what would sine of 30 degrees be?
half.
Yeah, because now it's far away from the y-axis. Sine's getting scared. It's pulling into its shell. It's only 1/2. Are you guys? Now again, you do not have to use my method to memorize these, but you must memorize them somehow. Yes.
So that means it would be kind of like flip for cosine. So cosine.
Yeah,
would be,
beautiful. Yeah. So cosine likes x. So what's cosine of 30 degrees? Is 30 closer to x? To the x-axis?
Two.
So then what's cosine of 30? It's got to be the
Radical 3/2.
Okay, 3 over.
the bigger one. Square root of 3 over 2. Kick ass. You guys follow? And let me really make a big deal out of that for a moment. Okay. Let me see if I can do this. My drawing skills are epic for how bad they are. See there? It's got to comb over my poor little circle. Okay. So here is 60 degrees, and here is 30 degrees. Can you guys understand these two triangles are the same triangle? This angle here is 30. This angle here is 60. So what is this angle? That's 60. This, of course, is 90. So what angle is this?
30.
30. Do you guys understand? Those triangles are the same. That explains a very basic identity between the trig functions. Whatever sine of 30 degrees is, that is what cosine of 60 degrees is. Because they're the same triangle. So this would be how long this side is, right? That's what the sine is, y. And so whatever this is, it also is what this is, which is what the cosine of 60 would be, because now this is the x side of that triangle. I don't know if this is something. Baby. 30 degrees, close to the x, sine don't like it, it's 1/2. 60 degrees, it's closer to the y, cosine don't like that, so it's 1/2 also. Up there. Okay, maybe. So sine slowly grows. Why? Because I'm slowly getting closer to the y-axis. Cosine slowly shrinks. Why? Because I'm slowly getting further away from the x-axis. What then is cosine of 0 degrees? If cosine loves the hell out of x.
Maybe.
1.
1. I mentioned this before when we were doing specific triangles. Help me out. Is everybody cool with the fact this has got to be big because cosine likes x and it's on the x-axis? In fact, what is this? This is the unit circle, correct? So what is this length?
The radius?
In the unit circle, that is
1.
1. Okay. And do you guys see, if I keep pushing this triangle down and down and down, do you see how the x piece keeps getting closer and closer to 1? So I understand at 0 degrees, there is no triangle. But then it's like all x. There's no y. So all of the 1 goes to the cosine. And of course, the poor little sine dude, if I'm on the x-axis, is there a y piece? No. In fact, as I get closer, the y piece keeps getting smaller and smaller until it is 0. Okay. I like it. Now, to remind you, can somebody just tell me the basic, and now you see why I sometimes call this r, because it is the radius of the circle. What's the sine of theta?
It's y over r.
Good, y over r. What's cosine theta?
X over r.
What's the biggest side always going to be in that triangle that I drew?
R.
R. Can sine theta be bigger than 1? How does y relate to r, the numbers? You just told me r is always the biggest side, right? Therefore, y must always be smaller than r. So when I do y divided by r, I get a number that is less than 1. So what is the absolute biggest sine can be? 1. Same thing goes for cosine, for the same reason. Is everybody with me? Okay, I love you guys. So, what we're going to focus on first is breaking out of the first quadrant. Because everything we talked about so far is all about the first quadrant. So somebody help me out. In the second quadrant. In the second quadrant. What's true about all the y values? They're all above, so they're all positive. What's true about all the x values?
Negative.
They're all negative. Which trig function likes x? Cosine. So in the second quadrant, cosine is going to be negative because the x values are negative. It's that straightforward. SOHCAHTOA would not do that for you, right? I need you. I keep shitting on SOHCAHTOA for a reason. If you know SOHCAHTOA, you can use it, but you gotta let go of it because it only helps you this far, not forever. Okay. And the other way helps you for frickin' ever. Okay. So let me show you an example in the second quadrant. So let's say I'm at 135 degrees. So I'm in this unit circle. Oh my God, that's the best circle yet. So does everybody agree I would make this triangle back here? Can somebody help me out? What is this angle right there? All the way across would be how many degrees? What's this? All the way would be 180.
So it ends up being 45.
45 degrees. Does everybody see that? Is that cool? So that 45 degrees is how far away from the x-axis I am. The closest I am. Yes? Do you guys see that? Okay. That is the exact same triangle if I drew a 45-degree angle in the first quadrant. Not with my shitty. Well, we're telling you these ones. So if I drew a 45-degree angle in the first quadrant, that is a really bad triangle, circle. These triangles would be the same. Because it's got 45, 45, 90. They would have to be the same triangle. This is why you do not have to memorize like the sine of 135 degrees. That's not a separate problem. Because the sine of 135 degrees is going to be exactly the same as the sine of 45 degrees. This, what's sine like again?
Y.
Y. So this y piece and this y piece, they are the same. So what's the sine of 45 degrees?
Radical 2 over 2.
Oh, yeah, rad 2 over 2, 11. So what's the sine of 135 degrees?
Sine 2 over 2.
It's the same thing. Of course it's the same thing. Because I get the exact same triangle. So I'm trying to get you to understand. There are 4 quadrants in this damn thing. I do not have to memorize all of it. I just have to memorize 1/4 of it. I just have to memorize the first quadrant. Is everybody cool with the fact that sine is positive, of course, because sine is still positive in the second quadrant. Y is still positive, yeah.
Oh, I was just gonna say with the cosine being negative.
Beautiful. So what's the cosine of 45 degrees? Cosine of 45 degrees.
Rad 2 over 2.
Rad 2 over 2. So the cosine of 135 degrees would be negative cosine 45 degrees, so just be negative rad 2 over 2. So what ends up happening in every single damn quadrant, you already know, you've memorized the number part, you just have to figure out is it positive or negative. And that's where sine likes y, cosine likes x really comes in handy. Alright, so this angle right there, is what we call the reference angle. It's called that because it's in reference to the x-axis. Whatever angle they give me, I rotate through the circle and then I figure out how far I am away from the x-axis because that would define my triangle. That would be the same in the first quadrant. I've got all that shit memorized. Let's do another one. So what if I needed to know what the cosine of what? 240 degrees. Can you guys take a moment, try to figure out, don't say anything, where 240 degrees would be.
Quadrant 3.
Don't say anything. And of course, this, so 0, 90, 180, 270, right? So if you remember that, you know it's going to be between these two, yes? How much, so if I rotate, I go 180 and then I go some extra, correct? How much extra do I go? If I go 240 degrees, how much past 180 did I just go? That is the reference angle. Isn't that the angle that it makes with the x-axis? So whatever the hell triangle I make, it's exactly the same triangle I would get for 60 degrees in the first quadrant. So cosine of 60 and cosine of 240 are going to be related. It's the same triangle. So cosine of 240, we got the reference angle is 60 degrees. Is that cool? It's always, the reference angle is always, how much did you go past or how much did you stop short of the x-axis? That's what the reference angle always is. And the power of the reference angle is, it would set up a triangle, it'd be the same damn triangle it would be in the first quadrant, so all the shit I memorized there comes in handy. I don't have to memorize cosine of 240 and all that. No, I don't. So the cosine of 240, what's wrong if I say it's equal to the cosine of 60?
Because it's negative.
It's negative. There you go. So this is how you be nice to yourself. That is because you know what quadrant it's in. That is because you know the reference angle. And what's the cosine of 60 degrees? Kick ass. Because 60 is far from the x-axis. Cosine don't like it there. Okay. I like it. How you guys feeling? I mean, this, compared to some stuff we've done, this isn't that terrible. There's a bit of memorization, of course, but I try to give you ways to memorize it. But once you memorize the first quadrant, you got everything. All right, so let me give you a problem to try completely on your own. Try to figure out sine of, what do you got, Jeff? 330 degrees. Corrections, of course. Anybody else not get their quiz back? Oh, sorry. All right, so let's see, which quadrant did you end up in?
Fourth.
Yeah, and how short did I stop of the x-axis?
60 degrees.
What's the x-axis again? If I go all the way around, it's 360. So 330 is how short?
30 degrees.
30 degrees. Exactly. Cool. So finding the reference angle has to be easy. That's all I do. How short or how much past the x-axis did I go? That's all the reference angle is. So whatever triangle this would be the exact same triangle in the first quadrant. What's true about sine here, though?
That's 1/2?
No. What's true about sine in this quadrant? It's
Oh.
negative. So this is going to equal negative sine of reference angle.
Right.
And like you said, sine of 30 degrees is
Negative 1/2.
1/2. I like it. Yes?
Why is it 1/2 again?
Sine likes,
X.
no.
Oh,
So sine likes y. 30 degrees is far away from the y-axis, so sine should be the smallest option, which is 1/2.
oh,
Yeah, when you go all the way to 0 degrees, then sine really hates that shit. It's 0, right? 30, it's like, and again, that's just one suggestion. That's the weird ass way I remember it. But that sine likes y, cosine likes x, it's insane how it helps you through everything. That kept going through all my upper level physics courses. If I just remembered sine likes y, cosine likes x, that helped me do all this weird ass shit. SOHCAHTOA did not help me. Okay, all right, let me try a little bit worse. Yes.
So for the, in ratings, do you have the option of, square root 3/2 1/2 and square root 2/2? Like, are there limited?
No, so radians are just another way to measure, well, I'm gonna do some radian examples in a minute, but I wanna start with degrees, because they're all more comfortable with. Radians are just another way to say the degrees. It's not gonna change the outputs.
But like the 1/2, is that one of only a few options?
For the ones we have to memorize, yes.
Okay.
So for sine and cosine, the only possible outputs are 0, 1/2, rad 2 over 2, rad 3 over 2, 1. And then negatives of those, depending on what quadrant. Are you guys with me? Tangent, you can memorize that if you want to. It could be rad 3 over 3, or 1, or 0, or undefined. Right? Stay with me now. So talking about tangent, let's do what tangent? Let's do a tangent of negative 120 degrees. Negative angle just means I go clockwise, right? A lot. So make sure everybody's on the right track. What quadrant do you end up in?
3rd.
Yeah, because they go past negative 90. How far short of the x-axis do I stop?
60 degrees.
So one very important thing to realize about the reference angle is it's always positive, right? That is how far short I am from the x-axis. So the reference angle is always positive. Now it's just a question of how do you have tangent either memorized or are you going to build it? What do you think about, so let's do this. What's tangent? Tangent is what over what? So it would be
Sine
y
over
over
cosine.
x. So what trig function would be on top? Right? And what's true about sine and cosine in this quadrant? They're both
Negative.
negative. So the tangent's going to end up being
Negative.
positive.
Oh.
Negative divided by negative is going to cancel. So this is equal to sine of the reference angle divided by cosine of the reference angle. And just to show you, this would equal negative sine, negative cosine, and these would cancel, correct?
Yeah.
Okay. Or you could have, from the beginning, you could have said, oh, sine and cosine are the same sign, so tangent's going to be positive, and then not even worry about, just make it positive at the end.
Yeah.
So this is one way to do this. Just memorize sine and cosine and then build tangent as you need it. So you have less you have to memorize. What's the sine of 60?
Rad 3/2.
Good. And what's the cosine of 60? 1/2. And then the over 2's cancel. So I end up with rad 3. The way I would do this, I finally have tangent memorized. Just because I've been teaching this long enough, it finally just sort of like crept in my brain. Tangent is big when sine is big. Sine is big at 60, so tangent's going to be rad 3, not rad 3 divided by 3. It's going to be the bigger one. You don't have to memorize. You can just do exactly this. Yes? Less stuff to memorize is always good. You only have so much stuff, space up here. Okay. How you guys feeling about this? Is this all right? So we proved why 30, 45, 60 has the sine and cosine outputs they do. We proved that. So now you memorize it, and then you can build for any quadrant we're in. All right, so what about this here? What about cosine of 5 pi over 4? Try to stay in radians.
5 pi over 4.
Yeah, so real quick. Remind me, in radians, I'll start. This is 0. What's this? In radians.
Pi over 2.
Pi over 2. This is a full pi, right?
3 pi over 2.
Good. Okay. So 5 pi over 4, is it more or less than a full pi? It's more than a full pi, so I'm going to rotate more than pi, yeah, from your perspective. This. How much past pi am I going to go? How much more than a full pi do I got? I'll stop saying pi like that, I'm sorry. How much more than a full pi do I have? 1/4. Yeah, 5/4 of a pi is 1/4 more than a full pi, so my reference angle is pi over 4, that's it. So my reference angle, I don't care if it's radians or degrees, it's always how much did I go past or how much did I stop short of the x-axis.
I'm sorry, what does it say cosine of what?
5 pi over 4.
5 pi, okay.
And I probably got my pi pretty good.
I just
Now.
thought it was S, so then I got confused.
Okay. So I am in quadrant 3. What's true about the x values in quadrant 3? They're negative, so this is going to be negative cosine of the reference angle. And it's okay right now if you have to translate pi over 4 back to degrees, but try to live in the radians as much as you can. Who remembers what pi over 4 is in degrees?
Rad 2 over 2.
No, I mean what pi over 4 is in degrees. 45 degrees, yeah. So what's cosine of, plus 45 degrees?
Rad 2 over 2.
Yeah. So ready with me? Cosine and sine are both equal at 45 degree angles. Okay. This would be negative rad 2 over 2. So real quick, what if I had asked you what the secant of 5 pi over 4 is?
That'd be like the
Say this is
cosine.
part A and this is part B.
It'd be the reciprocal of the cosine.
So if I ask you this, you would do this, and then like Mike just said, flip it. And flip it good. There you go. Okay, thank you.
Would be good.
And then of course this, I gotta do a little bit something with this, yes? Yes, rationalize it. So we get negative rad 2 over 2, and the 2's of course cancel, so we get negative rad 2. So just reminding guys, this would be on the quiz and the test, it would be, you could not use a calculator, right? If you can use a calculator, you could check your work. Right? Now what's weird is, let's try this. Okay, let me show you. Did I remember 21st night of September? No. I didn't remember to bring any damn thing. Well, maybe I won't do it. I don't have any calculators. Somebody have a calculator to borrow? Can I borrow yours real quick? Thank you, thank you. I just want to show you. if I want to do secant of 5 pi over 4, what's the very first thing I should check?
If it's in degree or
Yes, so let's see, mode. Jeff, you almost got it, buddy. Mode. I'm in degrees, so let me change to radians. So now, how do I do secant of 5 pi over 4? Is there a secant button?
No.
Would it be cosine?
I would do 1 divided by cosine.
Yeah.
Why is it doing that? It's weird. Oh, I see, it's glare. 1 divided by cosine of 5 pi over 4. So, of course, we're going to get something a little gross. So how do I really check this then?
I have a question.
Sorry, yes.
Could you do the second cosine do the same thing?
No. Okay. I'm glad you said this. Real quick, guys. Maybe not real quick. If I said f of x is x cubed, what does this mean? Does that mean just flip this? That means the inverse, which is cube root, which is not just flipping this. So that right there is in our future. Whenever we learn a function, we're going to just say we're going to graph the hell out of it, and we're also going to learn its inverse, so then we're able to solve equations that they live in. So this is in our future. That's what that button means. Be careful. It doesn't mean 1 over. It means the inverse of cosine. Yeah. So how do I check this? Well, the answer I got was negative rad 2, so I just put in here negative square root of 2, and thankfully they're the same number, so I checked it. You guys see what I'm saying? So I know sometimes students are confused about how to check this when you get these decimals. Well, then you just take the answer you got and do it also. See if they're the same decimal. Yeah, lock it. Thank you very much. Be careful, I changed the mode. All right. So here, try one more here. I want you to do the cotangent of negative 5 pi over 3. And the way to think about this physically, that will make you want to go get some pi is to think of it as a certain amount of pi. If that was 6 pi over 3, how many pi's do I have? 2. I have a full 2 pi's, correct? So negative 2 pi, where would that take me all the way back to? 0, correct? So I didn't go quite the full 6 pi over 3 back, did I? So I should stop short by how much? How much of a pi am I short 2 pi's?
1/3.
1/3. So I'm going to go back and I'm going to stop short pi over 3. So you're actually in the first quadrant. You guys with me?
Could you repeat that one more time?
Definitely. So if I went all the way, that would be 2 pi. 2 pi is also 6 pi over 3. So I'm not quite going all the way back. I'm stopping short by 1/3 of a pi. If I went 1/3 of a pi more, I would have went all the way back to the x-axis. So I'm missing 1/3 of a pi to make it all the way, so that's how far short I am.
And then, because it's the x-axis, but it seems closer to the y-axis.
Totally. Reference angles, always in reference to the x-axis. Like. Because then, the triangle it sets up, this is the x piece, this is the y piece, then it relates to all the stuff we already memorized. Okay. So of course, I'm in the first quadrant, everything is positive. And what's cotangent? What over what?
Y over x,
Okay, so what trig functions?
sine over.
No, it's not y over x, it's x over y.
Oh,
Yeah, you're thinking about tangent.
oh, that's right,
Yeah.
okay.
be a negative since?
No, because I'm in the first quadrant, everything is positive.
Yeah, but wouldn't it be like negative cotangent?
No, why? What's up? Sorry.
Oh, never mind, I get it.
Okay.
Oh, I see.
Now, I think you're worried, let me make sure. Brooke, are you worried about the identity for like cotangent and negative theta or something?
I just got confused because I was looking at the last problem,
Okay.
which we used the negative.
Yeah, so this is all about where I end up. I ended up in the first quadrant, so therefore everything's positive.
Okay.
Yeah. What's cosine of pi over 3?
Half.
Yes, cosine of 60 is 1/2. So what's sine of pi over 3?
We had 3/2.
Yeah. So the over 2's cancel. And of course, what must you do here?
You gotta, what you do here, I forget what do you call that?
Rationalize.
Rationalization.
Yeah. Not the psychology
Sounds
definition.
like a
rationalize.
rationalization, but.
Yeah, yeah. Exactly. Okay. Okay. These are just the nuts and bolts of trigonometry. Right? We're just learning some of the basic values. Of course, we're going to do a lot of problems in the calculator because the angles are all, not always nice angles. The angles are whatever the hell they are in the problem I'm looking at. But we need to memorize a few of these things. Okay. So let me see what you guys think about this kind of problem. Let's say I've got a triangle. This is 30 degrees, and this is, let's see, this is 7. Can anyone figure out anything else? Let me make sure you guys understand. It's a right triangle. What would this angle be?
60.
Holy shit. Now, real quick, can anybody figure out what that x is? I think we did a problem like this. See, now I'm going to get confused because I'm teaching a trig class and this. I told you the y side, correct? And now I'm asking about the x side. So which trig function relates what you know with what you want to know? Because do I currently care about the hypotenuse? So I'm not going to use any trig function that has the hypotenuse in it because I don't know it and I don't care about it. Poor little dude. Which trig function relates these two? Tangent. So tangent of 30 equals 7 over x. Kick ass. Can you solve that for x? So let me do this. 30 degrees is an angle you're supposed to know. You could break it down to sine and cosine, blah, 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 but let me see if anybody gets what I'm about to say. Tangent could be rad 3, it could be 1, it could be rad 3 over 3. When sine is big, tangent's big. When sine is small, tangent's small. 30 degrees, sine don't like that. So this is going to be rad 3 over 3. And now how do you solve that?
7 times 3.
Yeah, cross multiply. Now you can rationalize this, but let's say this is a physical problem that's like 7 feet. Can somebody tell me how many feet this is? How many feet?
It's 21 over rad 3b.
That's crazy. Give me an approximation.
12.12.
Say again?
12.12.
12.12. You guys with me? So now I can figure out stuff about a right triangle when I only know one side. I just have to also know one angle. How could you get this side now?
Pythagorean theorem.
Yeah, I could use Pythagorean theorem, or I could use sine. Yes? You guys with me? So there's going to be problems in the homework that give you parts of a triangle and say, find all the other sides and all the other angles, right? Well, the other angles are easy. It's going to be 90, correct? And the other sides, you're going to have to start with trig because you're not going to have enough information to do Pythagorean theorem at first, right? But now that we know this side, I could all day do Pythagorean theorem to figure out r. Yes? You guys semi with me? Yes?
Why do you use the 30 degrees as opposed to 60?
Because 30 is in the base. It makes it easier with how I memorize things. Cotangent of 60 would equal 7 over x. You know, gets a little worse, yeah. Okay, I like it. Maybe? Okay. So let me give you this. Give you this, we'll talk about it real quick. It's got a little bit of a preview of stuff to come on it too.
Sorry. Thank you.
All right, so I only give this to you as reference. I promise you guys, and I will stick to it because I hate this shit. I'm never going to give you a blank unit circle and make you fill it in or any of that bullshit. It's much, real quick. Cosine likes x, sine likes. So if you notice, all these points they give you, the x piece, of course, is the cosine, and the y piece is the sine. There you go, right? But I'm never going to make you fill the points in, because the points themselves don't mean shit. What matters is the components, and we've already got those memorized. You guys kind of with me? So you should be able to do it, but it's just kind of dumb. One reason I like to give this to you is to really help you get used to the radians and what degrees they are. So you can kind of have this to reference, but you want to live in the radians as much as you can so you can get more used to them. Yes? This is a little preview. We'll talk about why the graphs look the way they do. Especially look at this graph. That's funky. That looks like a cubic, yeah? That's tangent. Sine and cosine, I'm sure most of you guys knew already sine and cosine. That's oscillatory, they just kind of do this. Secant and cosecant are freaky as hell. We'll talk about why that's true later, so I don't mind you get this a little bit early. There's the basic definitions. There's the tangent stuff, reciprocal identities, blah, blah, blah. Okay. So let's look at the other side. Curious. We haven't done a problem exactly like number 1 yet. Try to do something with number 1. I want to see what you guys do. By the way, that's always a weird phrase to hear a teacher say, but I had a teacher one time who put a problem on the test, and he later said, oh yeah, I put that on there just to see what you guys would do. And we're like, oh, you know, this is not great, I don't care. Do what you can with number 1, then we'll do it together. So let me ask, does anyone have something they're currently trying to do with this problem? Say again?
Finding X.
Find,
So that there's Y in each.
oh, okay, you gotta be really careful. Sine theta being negative 6/7, does that mean that the y side is necessarily, no. So you gotta be a little careful, but if you're doing it right, this will work. Are you drawing a triangle? No, okay. Are you doing Pythagorean theorem though? Oh, okay, good. You gotta always be careful, and generally have to be careful. I know sine theta is negative 6/7. Does that necessarily mean that the y side is negative 6, or is 6, or whatever? No, it doesn't. But if I draw a representative triangle with the correct sides, it's always going to reduce to be that, so that I can keep going. So it's basically what you're doing. You didn't draw it, but you're doing Pythagorean identity, so you're doing it. Pythagorean theorem. One of the easiest ways to do this, you could do it, well, let me see. Here's one way that I see a lot of students like to do it. I'm in the 4th quadrant, correct?
Yeah,
So therefore my triangle will be kind of like this,
yeah.
which explains why this side is actually going to be negative. Is that cool? Now, this is the first time we've ever seen a triangle where a side is negative, but it's not a physical thing, it's a direction. It's negative 6 just because it's going down, right? It's like 6 feet below the ocean. So then what's this side here?
And that's the
7.
button.
So from this, I can immediately draw this triangle. Now, Noah's got a great thing. If I just knew this side, I could construct all the freaking trig values, correct? So how do I figure out this side?
7 squared minus 6 squared.
Yeah, 7 squared. Let me do this. Equals x squared plus negative 6 squared. Is that cool? So 49 minus 36 equals x squared. Is that 7? Am I doing this right? 36, 49, yes. Become a thing. You can do it better, Jeff. There you go. 13 equals x squared, so x equals square root of 13. Okay. Let me stop for a minute. Since trig functions are based on right triangles, you're going to be looking for right triangles. You're going to try to draw right triangles, because that's going to make everything else easier. We're going to learn a different way to do this later, but then I don't care which way you go. They're actually mathematically the same. So now, for example, if I put rad 13 here, here's theta. Sine theta, I know. Even before I drew any damn thing, what's cosecant theta?
1 over minus 6 over.
So you just take sine and you flip it.
Flip it.
There we go.
7 over minus 6. Oh, minus.
Doesn't matter where the negative, we normally put it up top.
Okay.
Now looking at my triangle, what would cosine be?
Root 13 over 7.
Yeah, root 13 over 7. I love it. It's the x over the hypotenuse. So what's secant going to be? 7 over root 13. I rationalize it, so I end up with 7 root 13 over 13. What about tangent?
Negative 6 over
Yeah, so it's going to be the y piece over the x piece. Negative 6 over rad 13, which becomes negative 6 rad 13 over 13. And then cotangent, just to kind of remind you guys, don't flip this stupid thing. Flip this. Maybe not remind you. Again, this is going to be really weird for me. I've never taught trig in 2 different classes at the same time.
Rad 13.
I could flip this, but dear God, I'd much rather flip this. Because these are both the same stupid number, yes? So I'd much rather just flip this and be done with it. There we go. So if I have enough information to set up a right triangle, I can answer all the damn trig values easy. This is not memorization. This is, well, it is sort of. You got to remember what sine, y over r, so forth. Okay. But it's not like sine at 30 degrees. These are the problems that we just did, right? these guys.
Yeah.
So for example, alright, I don't know if anybody's tried this out yet. Do 2A real quick if you haven't done it yet. Try to do 2A. See if you guys remember the thing we did earlier about how short are you of so many pies. So we're all, or most of us are relatively new to radians. So we don't, it's sort of like solely trying to do a decimeter or something when you're an American. It's not an easy thing. But you start to realize how I'm really close to 12 pi over 6. And what's 12 pi over 6?
2 pi.
2 pi. So how far away from 12 pi over 6 am I? 1/6 of a pi. So I'm not quite going to full rotation, I'm stopping short by 1/6 of a pi. I love it. So you didn't quite rotate all the way around, you stop just short by pi over 6, and that's exactly how you find that referencing. And the reference angle kicks ass because it puts us in the first quadrant. That's where I have everything memorized. Yeah.
So is this wasn't clear to me, is the reference angle the one closest to it?
X-axis
Okay.
always. Cool. Because again, I want this to make sense. What do we have memorized? I have memorized 30 degrees in reference to the x-axis, right? Every angle we have memorized is in reference to the x-axis. So that's why I want the reference angle to be
Okay.
related to the x, because then it relates directly to what I already have memorized. We could have memorized every damn thing related to the y-axis, but we don't.
Thank you.
You're welcome. What's true about sine in this quadrant? What quadrant am I in, by the way? And what's true about sine down there?
Sorry, that's why.
So what's true about it?
It's negative.
Negative. So this is going to equal negative sine of pi over 6. And what's sine of pi over 6?
Half.
Good. Sine likes y, pi over 6 is close to the x. It's going to be small. Poor little dude. Okay. All right, part B is a little bit easier because this is degrees, but try to do part B. All right, so what quadrant do you end up in? Second? How short did I stop? 45? And what's true about cosine in that quadrant?
It's negative.
Yeah, so this will be negative cosine,
And
45
rad
degrees. Of course, 45 degrees is your friend. Cosine and cosine are
rad two.
rad 2 over 2. Cool.
And cosine's negative and sine is positive.
I like it.
Good job.
Okay. Right? This isn't too evil. And again, I understand the party brain is like, great, this is numbers. I'm getting numbers, yay. Do they mean anything? Well, yeah. It's that one example we just did a minute ago about seeing how. So the problem we did where I walked away from a tree and so forth. I mean, this is the basics of trig, and then what you can do with it is insane. Yes.
If it was closer to the y-axis, would it be the 3/2?
Yeah, of course. So 45 splits the difference between square root of 1/2 and square root of 3/2. So that's square root of 2/2. So yeah, if it was closer to the x-axis, it would have been rad 3/2. Because we're talking about cosine, right?
Yeah.
So if it would have been cosine of 150 degrees, that would have been rad 3/2. Yeah. If it was cosine of 120, that would have been 1/2. Negative. Yeah.
Why is it negative again?
Do you see the quadrant? We're in quadrant 2.
Yes.
What's true about all the x values there?
Oh, they're all negative.
Negative. Right? Just to shit on SOHCAHTOA. SOHCAHTOA doesn't help. Cosine likes x, so where x is negative, cosine's negative. Sine likes y, so where y is negative, sine's negative. Yeah. So what quadrants is sine negative?
2 and 4. 2 and 3.
Where is y negative? Which quadrants?
Oh, y.
3 and 4. Yes? Where's cosine negative?
1 and 2.
Yeah, 2 and 3. Sorry. Alright. Here, I want to do, I'm going to let you guys out a little early because I got to run up to my office. Let's look at this problem here real quick. We'll finish this up, don't worry. This is kind of like what I did with you earlier, but one little difference is the angle I give you, one that you have to have memorized. No. So that's pretty much telling you use a calculator. But you still got to set it up, correct? So let me label some shit here. You guys agree with me that that angle is in the base because it's next to the x-axis? So what side would this be?
Y.
Y. And this, of course, would be the hypotenuse of the r. By the way, this is a physical triangle, so there's no negative sides. Yes? I just did this just to show you why this is x, this is y. This is a physical triangle, so nothing's negative. So what angle, for example, if I want to figure out what this is, what the hypotenuse is, what trig function relates what I know with what I want to know? Cosine. So the cosine of 43 degrees would equal 24 over r. Kick ass. So then I would multiply by r, divide by cosine, so I end up with this, and then this I would just throw in the old calculator. This would be roughly, huh?
Could you, I don't know if this would help, but find the other angle in there? Or
Yeah, of course. Yeah. You could, but it won't really help me
It won't.
because it's not in the base. This angle's better
okay.
because it's in the base.
Oh,
Yeah. Does anyone hit this? Hit this? Heave it? I think it's like 34? 33? I'm trying to do it in my head. Somebody save me from myself. Nobody wants to say.
43.23.
Oh, I was nowhere close. Okay. 43 point. 23? No, it can't be 23. What's happening? That sounds better. 32.81. That sounds better. Okay. I like it. Alright. Next time we'll finish this up. I'll let you guys out a little early. Don't get used to it.
Oh, yeah.
Yeah, I think we'll do a quiz on Tuesday, everybody. I'll tell you on Monday what section done. There will be a quiz on Tuesday. Probably 7172.